Hello, everyone. Good morning, good afternoon, good evening to everybody all around the world who are joining today's session. So, my name is Sina, and I'm the community admin of Microsoft Fabric Cafe. I'm super glad to be here again. First of all, I'm gonna apologize for any inconvenience happened last week's. So we had to cancel some sessions because of the technical issues. But I'm super happy to be here with another amazing session. So I'm not gonna waste any time. I'm gonna see just add the slides to the stage and see what we have today. So today, October 26, 2024, 8 a.m. Pacific time, session 12, Fabric Coffee at Microsoft Fabric Cafe. So here's is today's agenda. So our guest speaker is Nikola. He's going to be here with us shortly. So of course we have questions and answer during the session. Just if you guys have any questions, just put in the comment sections, and it will be definitely answered by Nicola. And of course, we have riddle and prizes at the very end before ending the sessions. And just a quick reminder, so guys, we just accept those answers just on StreamYard, nowhere else. Just make sure that put your answer on StreamYard's like chat box. And so about the Microsoft Learn community, so everybody knows that it's a tech community to stay updated with the latest news and ask questions and explore certifications with expert guidance. And if you guys just interested, just there's a link aka.ms/learning rooms. You can just join there and choose your rooms based on your like specific languages, like your interests. And of course, one of those rooms is your room, actually, Microsoft Fabric Cafe. It's a Microsoft Learn community, as you know, and we concentrated on Microsoft Fabric, trying to provide learning and support to Fabric user in all levels, and a forum for everyone to learn, share, and grow skills together. And of course, in our cafe, learning meets fun. So, and as you guys can see, we have our social platform links. So YouTube and LinkedIn and Microsoft Learning Rooms. Just make sure click those links and follow us. And and there's a code of conduct to keep actually our community positive. And thank you for being part of our community, to be respectful, to having collaboration and embrace diversity, and use responsibly. And if there's any issue, just report them. And during this period of time from September 24th until November 1st, as you guys know, it's AI skill challenges, and you guys can register for them. And there are lots of challenges, and one of those is Microsoft Fabric, and we are actually your support. And we have sessions during this period of time, and after complete those sessions you will earn a digital badge. And during this period of time we have sessions, as you guys know, we are already done with two of those, and some of those, as I mentioned earlier, have been canceled due to technical issues. And today's session is with Nicola. And for these upcoming sessions, as you can see, so the registration links have been introduced on our social platform, and you guys can go for it and just set your calendar and register for them. And yeah, we have, as I mentioned, we have Nicola today. Let me just remove this and add Nicola to the stage to see what guest we have today. Hi, Nikola. How's it going today?
Hi, Sina. Good to see you. Yeah, all good on my side. Hope it's the same on yours.
Oh yeah, thank you so much. Thanks for being here and thanks for your time. I know it's like almost 5 p.m. there, right?
Yes, that's correct. Yeah, thanks for having me. It's my pleasure to join
Our
Fabric Cafe.
pleasure. Thank you so much. Thank you so much. So, Nicola, I'm not gonna waste any time. I'm gonna just share your screen and hand it over to you, and all yours. So,
Thank you so much. Thank you.
no worries, man. And this is
Okay, so
yours.
yeah,
So the stage is yours. I'm gonna be in the back end stage. Is there any like question? I'll be there right away.
thank you, thank you
So
so much. Thank you
thank
so much.
you so much. Here we go.
Thank you. Yeah, so hi everyone, and as Sina said, good morning, good evening, or good afternoon, depending from which part of the planet you're joining this session. And today we are going to talk about one of the uh, most most impactful features in Microsoft Fabric, and it's Direct Lake. And you will see why I consider this as one of the most revolutionary features that Fabric introduced. So before we start, just a short introduction of myself. My name is Nikola. I'm originally from Belgrade in Serbia, but for last almost 9 years, I live in beautiful city of Salzburg in Austria, where I work as an independent data platform consultant and trainer, focusing mostly on Power BI aspect of data platform and, of course, working a lot with Microsoft Fabric. Recently, living in Salzburg was the reason why I've chosen this nickname, Data Mozart. You probably heard that Salzburg is a birthplace of this great composer. So yeah, I was brave enough to use his last name as part of my nickname, and that's why I'm trying to make music from the data. Other than that, yeah, currently involved in one project of writing a book for O'Reilly together with my friend Ben Weissman. We are writing a book called Fundamentals of Microsoft Fabric. Early release is already available online, but yeah, we hope to finish the book and have this printed edition beginning next year. So if you are interested in learning more about Fabric, yeah, go ahead and check this book. That's what I can say. Privately, I'm father of two kids, and through football and bars of fun, as you can conclude looking at the photo on the screen. So short intro to agenda for today and what we are going to cover. First, I'll talk about different storage modes in Power BI. Then we will discuss the importance of storing the data in Parquet or Delta format within Microsoft Fabric. Then I'll introduce you to a key concepts in Direct Lake, things that you need to know in order to be able to successfully implement your Direct Lake solutions. Of course, then we will talk about some benefits and some limitations of this new storage mode. And of course, by the end of this session, I'll share my view about when it makes sense to go this way and use Direct Lake in your Power BI semantic models. Of course, there will be enough time, I hope, for your questions. And we also prepared some riddles for you to win some nice prizes, but more on that by the end of the session and when Sina joins again. What I wanted to tell you, if you have any questions during the session, you don't need to wait for this last part. Feel free to ask them in the chat window. I'll try to monitor chat window and then try to get back to you with the response as soon as possible. Okay, so let's jump into the action. And first of all, I need to do a short disclaimer. And when I'm doing this session in person, I ask people, do you know what this function, this is a DAX function today, what does this function return as result? And obviously, most of people know that it's today's date. And why I said this is a disclaimer, because everything that I tell in this session today can be changed. So things are changing rapidly in Fabric, as you probably know. So this is a rapidly evolving platform, still very new platform. And literally every week we are getting more and more new features, updates, improvements, and so on. This is Direct Lake is not different. So Direct Lake as part of Fabric is also rapidly evolving. Therefore, I wanted to say that everything I say today is relevant as of today. If you watch recording of this session in a few weeks or few months, and you see me talking about some limitations, and those limitations are not considered limitations anymore, Please keep in mind that as of October 26th, things that I mentioned in this session are relevant. For after that, I don't guarantee. Just a brief introduction to Microsoft Fabric from a high-level perspective to put the entire discussion about Direct Lake in the proper context. And just because I'm not sure, we are not in the same room, so I cannot ask you, have you ever tried Fabric? Did you hear about Fabric and so on? So I assume you maybe heard about Fabric, but those are the core components of Microsoft Fabric platform. And you can see what is the task, or let's say the strength of each of these components here. So I'll not spend too much time, but just to give you a brief overview, we are going to talk today about Power BI, of course, and also we will mention some, so this part here, Power BI, but also we will mention some other components such as data engineering and data warehouse, because basically you're building your models on top of the data that is stored within a warehouse or lakehouse, or to be more precise, in the end, all your data in Fabric is stored within one lake. I see we have a question, how Fabric is better than Snowflake in terms of data storage features, and then we are missing. We can discuss this by the end, so it's a very broad topic, and I wouldn't say it's better or not, yeah, but let's discuss this by the end of the session. So you are a Power BI professional, I assume, and then you want to transition, or you heard that there is a new player on the field, which is called Microsoft Fabric. And now you're wondering, what should I do now? I learned Power BI, I know Power BI, but now with Fabric, all these new things that are coming, what should I do now as a Power BI professional? And what I'm telling people, relax. There is no any single reason to being stressed. All your current Power BI skills and knowledge are still absolutely applicable and valid in the times of Fabric. Obviously, you need to learn some additional things, but that's I hope that's the case. Nevertheless, of Fabric introduction or not, we are here to learn as much as we can. So whatever you learned about Power BI and whatever you know about Power BI is still absolutely relevant. That's my message to you. So don't be too stressed with now the Fabric introduction. We need to do one step back and just reiterate through the architectural choices before Fabric came into the place. So before Fabric, we had two main storage modes in Power BI. The first one, the default one, is called import mode. So essentially what happens when you select import mode for your semantic model in Power BI is that Power BI will create a copy of the data in its own database, which is called Vertipack. So this part here on the left-hand side, this is your source data. This can be SQL database, Excel file, SharePoint list, whatever is considered as a source for your data. And then essentially you have a process where you create a copy of this data and store the copy of this data here in Power BI's database. This cube in the middle, this is Vertipack, this is Power BI's database. So we are taking the copy of the data and we are storing this data in Vertipack. And then when users interact with the report, so they click here and there, in the background, all your visuals are generating DAX queries. And these DAX queries are then executed against the local copy of the data which is stored in Power BI's database. So these DAX queries here, they don't have any access to your original data source. They are just querying data from the local copy stored in Power BI's database. And the biggest advantage of import mode is blazing fast performance. So you probably know, if you work with Power BI, that even if when you are working with hundreds of millions of rows, sometimes billions of rows, results are returned very, very quickly. And this is possible because this Vertipack database is in fact columnar in-memory database. Columnar means data is stored and compressed within columns, which is great for analytical workloads. And in-memory means that your data is stored in cache memory. And because it's in memory, results can be retrieved fast and results can be displayed quickly in in Power BI visuals. That's the main benefit of import storage mode. But there are two downsides. First is data duplication. As I already told you, you are basically creating the copy of the same data within Power BI's database. So this data here and this data here exists in two places. So this is kind of a downside because you need to store the same data basically in two different places. And then we have another issue, which is data latency, meaning when you load the data into Power BI, it's a snapshot of your data at a certain point in time. Meaning now it's 5:15 here on my side in Salzburg. Meaning if I load the data now in my Power BI model, whatever comes here in the data source side, so here on the left-hand side, all the data that comes in here, my Power BI reports don't have idea about that until the moment I refresh my Power BI model. So in the meantime, these queries here will query the copy as of 5:15. And let's imagine that I loaded 1,000 rows and my next refresh is in 6 hours. So in the meantime, let's say that I have new 1,000 rows here in my data source. These 1,000 rows don't exist here until I refresh my data model. And that's why we are talking about data latency with import mode. To resolve these problems, let's say problems of import mode, Power BI introduced another approach, and this one is called DirectQuery. This one is totally opposite to import mode. So with DirectQuery, you don't store any data in Power BI's database. So this one here, the cube in the middle, just stores the metadata, information about tables, columns, data types, and so on. But when your user interacts with the report, these DAX queries here, they are automatically translated to SQL language, and then these SQL queries are executed directly against your data source, and results are returned back to your Power BI report. So what happens with DirectQuery is that we have a real-time data, basically whatever is stored here on the left-hand side in the original tables at the query time will be retrieved and brought back to Power BI report. So we resolve data latency. There is no data duplication. Essentially, we don't move any data, any physical data, we don't move to Power BI. So everything stays here in its original data source. Okay, and then at the query time, Power BI gets results. So we resolve data duplication, but we pay the price with slow performance. And I'm sure all of you who ever worked with Power BI know what I'm talking about. So with DirectQuery, performance compared to import mode is significantly worse. And that's the main reason why we are not using DirectQuery as our default choice, because performance is significantly worse compared to import mode. So those two options, import mode and DirectQuery mode, existed before Fabric was introduced, and they still exist. That's one of the key takeaways, I would say, from this session, because people are now thinking, okay, we have now Direct Lake, we don't need import or DirectQuery anymore, or maybe Microsoft will deprecate them. No, not at all. So import and DirectQuery are still here. They are here to stay, and you can still continue using them like you were using them before Fabric. But what Fabric introduced, and now we are starting talking about Direct Lake, is the third option, which is called Direct Lake. Now, if you ever watched any of Microsoft's presentations about Direct Lake, you will see the similar slide. But then here down below, it says this one is perfect because it resolves all the problems of both import and DirectQuery mode. It's not perfect, to be honest. Well, there is no such thing when working with data that is perfect. It is for some scenarios, but generally, I would say it's a too bold statement calling Direct Lake perfect. But what's the idea behind Direct Lake? So we had a problem with slow performance, and we had a problem of data duplication, data latency, if you combine all the problems in both import and DirectQuery mode. So what happens with Direct Lake? Power BI still doesn't store any data. So this is the same as with DirectQuery. So your data is stored within one lake, within Delta tables in one lake. Again, it's just metadata in Power BI. And then when user interacts with the report, these DAX queries are then being pushed through directly to a data source, which is Delta table in one lake, and results are then loaded here into memory on demand. We will explain and examine what this on demand means in terms of working with Power BI. But then based on what your query needs from those tables, this data will be loaded here in Power BI's database. And because data is very stored in Delta format, is stored very similar to the way it's stored here in Power BI's original database, Vertipec, because it's very similar way of storing data, similar compression algorithms, and so on. Power BI can quickly translate this data, load it into memory, and once the data is in memory, it behaves the same as import mode. So it's a combination, like a hybrid of features that both the import mode and direct query provide. There are certain prerequisites for using direct query, so let's go quickly through them. First, you need Fabric capacity or Power BI Premium, so either F or P capacity. So Premium per user doesn't work. You need a lakehouse with SQL endpoint for direct query fallback. We will examine later what does direct query fallback mean. Or warehouse. So direct lake is supported both for lakehouse and warehouse in Microsoft Fabric. Data needs to be stored in Delta format, so don't be baffled if you load your data as a Parquet format or I don't know, CSV, whatever. Direct lake will not work with that. So just Delta format. And then reordering, I've intentionally put this small asterisk at the end because it's not a hard prerequisite, but if your Delta tables are not reordered, and I will show you what reorder means, if they're not reordered, you will not get the best possible performance. And now if you're wondering what is reorder, in short, and very short, just one sentence, that's a specific Fabric, Microsoft Fabric way to additionally compress and optimize Parquet files when you write the data into one lake. So whatever engine you use to write the data into one lake, no matter if it's Dataflow Gen 2 or if it's a notebook or SQL engine, all of them are writing data by default with reorder to support these fast reading operations for direct lake scenarios. A short intro to Parquet and Delta, and I try to keep it as simple as possible, just to give you a hint why is this such a why Delta and Parquet are such a big deal in times of Fabric. So this is the example of how we store the data with traditional relational database management systems. If you think of databases like SQL Server, Oracle, MySQL, and so on, so we store the data as sequence of rows, okay? And that's very good for certain scenarios. But for analytical scenarios, this might cause some issues with performance when you read the data. And let me give you a very basic example. Let's say that your business users want to analyze how many t-shirts were sold in USA. With traditional row store databases, the engine needs to scan all 6 rows and all 5 columns. To get results, essentially we just need information from 2 tables, how many t-shirts in the USA. So we need information for product and country columns, but the engine scans everything, okay? Because data, as I said, is stored as sequence of rows. Then column-based storage, which was introduced approximately 15 years ago, and it still exists, of course, outside of Fabric and all these things. And this was intentionally built to support analytical queries. With column-based storage, each column is stored as a separate unit, okay? So they are physically separated from one from another. And in this case, to answer the question how many t-shirts we sold in the USA, the engine will scan just 2 columns. So it's capable of skipping the scan of columns that are not needed by the query. And then we have a third option, which is Parquet, that introduced another structure within the data storage. So all the columns are still physically separated one from another, so it's still separate units, but we also have horizontal structures called row groups. And why is this important? In analytical queries, we are mainly concerned with two concepts: projection and predicates. Projection refers to select statement in SQL. So which columns we need in our query. In our case, we need two columns. We need product and we need country, right? To answer our question. So that's projection. And then predicate, which refers to where clause in SQL statement. So which rows satisfy criteria within our query and which rows should be returned by our query. In this case, we are just concerned about t-shirts. We don't care about socks, right? So the engine can skip scanning those records within row group 2. Now, why is this important? If you take a look at row-based storage, to answer the question, how many t-shirts did we sell in the USA? The engine needs to scan 5 columns and 6 rows. For classic traditional column-based storage, is 2 columns and 6 rows. And with Parquet, it's 2 columns and 4 rows. Of course, this is oversimplified example, and on 6 rows, you don't see any difference in performance between these 3. But usually when we work with analytical data, we have hundreds of millions of records, and this can really make a huge difference in query performance. Can it be better than this? So far we talked about Parquet, but I told you that if you store data as Parquet, you can't use Direct Lake. So there is additional X factor or additional ingredient that these Parquet files need to be able to leverage them for Direct Lake semantic models. And this additional ingredient is called Delta format. Delta is nothing else but, I like to call this Parquet format on steroids. And when I say steroids, what Delta introduced is additional layer of metadata on top of Parquet files, which stores the information about the version of Parquet file, stores the transaction log of all the changes that you made, so you can go and do point-in-time analysis and so on. So with Delta log on top of Parquet files, we essentially get the similar set of functionalities that we have with traditional data warehouses. So that's a huge benefit of using Delta format. This is how one table in one lake will look like. So it consists of one or multiple Parquet files. As you see in this case, I have, I don't know, 10 individual Parquet files. And then I have this Delta log folder on top here. What does this Delta log folder tells me? It stores the information, as I said, about the version of Parquet file. In this example here, I have 8 different versions of Parquet files. By its nature, Parquet file is immutable, so you can't change it. Once you create a Parquet file and you store the data, if you change something, so for example, you update customer's address, it will not update the existing Parquet file, it will create a new file. And then this file will have a version with the next number in sequence. And then whenever you update your data, there is a new Parquet file, and things work that way with Parquet files. And Delta keeps the track of all the changes that you made. So what can you do in this case? You can use describe history command, for example, and then you can query specific version of the file if you don't want the latest one. By default, always the latest file will be queried in Microsoft Fabric. Now going back to Fabric and show what are the different options when working with Direct Lake. So we have 2 options. We can store our data in a lake house, and whenever you create a lake house in Microsoft Fabric, you get 2 additional items provisioned for you out of the box together with your lakehouse: SQL Analytics endpoint and default Power BI semantic model, which is by default in Direct Lake storage mode. So as soon as you create a lakehouse, you don't have to specify anything in addition. You will get these 2 items. These 2 items created for you: SQL Analytics endpoint and default Power BI semantic model. And then on top of this default semantic model, you can build your own custom semantic models. Their official name is not custom semantic model. And once you build them in a workspace, you will see they are just called semantic models. But just to be able to distinguish here between a default model and all the other models that you built, I call them custom semantic models. Okay. And then for a warehouse, it's a similar story. When you create a warehouse, again, you get default Power BI semantic model. There is no SQL Analytics endpoint because it's already built in within your warehouse. And then again, you can build your own custom semantic models. I'll skip shortly this demo because I have more interesting demo later. And then I want to explain how this magic behind Direct Lake is working. As I already mentioned, Parquet is very similar to how Power BI stores data when you're using import mode. So when you use import mode, if you recall from the beginning, I told you Power BI loads the data in its columnar in-memory database called Vertipack. And the way Vertipack stores the data is very, very similar to how Parquet stores the data. And then because of that Power BI engine is capable of reading data directly from Delta tables in OneLake. When you create your semantic model in Direct Lake mode, it's initially empty. There is no physical data stored in it. I will show you in a demo. And then it loads the data in memory on demand. Again, I will show you in a demo. It's much easier to understand when you see it in action. To explain what is really happening when you create a Direct Lake semantic model, I'll give you a brief overview of the things happening in the background. This is our Power BI user, and they have their nice, shiny Power BI report, right? And this report connects to a semantic model. This semantic model is in Direct Lake storage mode. Then we have another component, which is either Lakehouse SQL endpoint or warehouse, depending which one you choose, or maybe both of them if you choose to store the data in Lakehouse and warehouse in Fabric. And then we have a bunch of tables and views that are exposed from warehouse or from within SQL Analytics endpoint. And then finally, we have our OneLake as a central storage location in Microsoft Fabric. And then we have multiple Delta tables that are stored within OneLake. Now, when user interacts with the report, what happens is that only columns needed by the query will be transcoded from OneLake. So from this part here. So columns from these tables here will be transcoded and sent to a semantic model. Here, this one in Direct Lake semantic model. To illustrate on one very simple example, let's say you have two Delta tables in OneLake. One is customer, another is sales. And let's say that I have 5 columns within my customer tables and for customer table and 5 columns in my sales table. And let's say that my report shows the data within a table visual, which aggregates sales amount by first name. So what's going to happen when your user opens the report that has a visual with first name and sum of the sales amount is that only those columns that are needed by the query, in this case it's first name and amount, will be loaded into a semantic model. Nothing else. Or at least I lied a little bit. You also need relationship columns because of filter propagation and everything else. But what goes into memory, it's only columns needed by the query plus relationship columns, nothing else. So we don't care about last name, email address. We don't care about sales key, product key, and date. So these columns stay in Delta table in OneLake, and only columns needed by the query plus relationship columns go into memory. I'll show you this in a demo in just a few minutes. So this is how Direct Lake works, okay? This is a big difference compared to import mode. One more thing to keep in mind, when data is loaded into a memory, so from a table in OneLake to a memory in Vertipack in Power BI semantic model, the entire column goes into memory. So regardless of the fact if you partitioned your table, your Delta table in OneLake, and you have, for example, data partitioned on a year level, the entire column goes into memory. So at least as of today. We'll see if something changes. This is also important to keep in mind, and don't be surprised to see the entire column loaded into a memory. What happens if Direct Lake does not work for whatever reason? We will see some of the reasons later in the session, but there are multiple of them. But what happens if Direct Lake does not work? By default, queries will fall back to DirectQuery. So that means in this case, the query, the semantic model will switch to DirectQuery, take the data through the SQL endpoint, and then further propagate and take data from your Delta tables. I suppose I don't need to tell you that this is, again, all the issues we had with the original DirectQuery approach, so slower performance, you will face the same thing here. So that's what happens if there is no possibility to use Direct Lake. Now, a few concepts that are important to understand Direct Lake and its approach. First question that I'm getting is, what happens if my Direct Lake semantic model consists of, let's say, 5 tables, and then I get 5 new tables tomorrow in my lakehouse? Will this change be automatically reflected within my semantic model or not? And the answer is, it depends. So there is a setting called sync the default Power BI semantic model, this one here, which is turned off by default. That means if you have new tables in a lakehouse, until the moment you explicitly say refresh your semantic model, these tables will not be added to your default semantic model. So you need to open the option manage default semantic model and then add those new tables to a semantic model. Or you just turn on this option if you want this to be synchronized automatically. You just turn this option on and then all the tables will be automatically added. This is regarding new tables. Now we have another consideration. What happens if I have a table and I don't have a new table in the lakehouse? I have a table in my semantic model and new data is coming into my original Delta table. So let's say that I loaded data, as I said, at 5:15, and then new data is coming into my lakehouse. So I'm doing my ETL stuff. New data is added to my Delta table. What happens with this data within a semantic model? Again, it depends. But in this case, unlike with synchronization, in this case, Power BI will automatically check every minute if there is a new version of the file. Remember versioning of Parquet files. Power BI will check if there is a new version of the file, and then it will load the data. If you keep this option, keep your Direct Lake data up to date, if you keep it as it is, turned on, then Power BI will automatically check for the latest data. If you turn it off, then again, you need to explicitly click on refresh button of your for your semantic model, or do it in programmatical way, but you need to explicitly refresh your Direct Lake semantic model to get the latest data. What you prefer is, it depends on your business needs. For some scenarios, it makes sense to keep this option turned on, but also let's say that you have a semantic model with 10 different tables. You probably don't want your data to come one by one. So you want to finish the entire process of loading the data and then refresh the entire model at once. In this case, you turn off this option and then you handle data refresh on your own. When I say data refresh, it's not a classic refresh that we have in import mode. When you hit refresh button or you schedule refresh for your import models, so Power BI will go directly to a data source and pull up all the data from the data source in case you do a full refresh. Or if you do incremental refresh, then it will just check for data that is defined in for incremental refresh partition. But generally what happens, Power BI will go to a data source and will pull the data and physically move the data and store it in Power BI model. So the entire model, 1 gigabyte, 100 megabytes, 100 gigabytes, it doesn't matter. The entire model will be reloaded. So you move the data again and physically store it in a Power BI semantic model. What happens with Direct Lake? We don't have refresh the same way as we have in import mode, as I said. So this process is called framing. And why it is called framing? Let's pretend that our semantic model here consists of 4 different tables, 4 different delta tables. So this is a frame of our semantic model. This is currently in the frame of our semantic model. And then let's imagine that there is a new file that comes, new version of the file that comes into the lakehouse. So in order to have this latest file available here in semantic model, latest version of the data, what happens? First, everything that was loaded into a memory will go out. So Power BI will kick out everything from memory, and then it will expand this frame to include the latest version of the file. That's how the process of refreshing data or reframing the data works with Direct Lake. So I'll show you a very basic example. In this case, I have 2 Parquet files. As you can see, this is my first file and this is my second file. 2 Parquet files for my dim customer table. And I have 2 versions of this file, 00 and 001. That's the latest version of the file. That's the one that is currently queried by Power BI. What happens if I change customer address, email, whatever, is that now I have 3 Parquet files. So new version of the file was created. You can see based on the date modified that I changed something after 2 hours after I created the table. So I have a new version of the file, this one here. And in the delta log, there is another version 002. And this is the one that Power BI will now need to take to be able to display the latest data in the Power BI report. Keep in mind, another key takeaway from this session is that unlike with import mode, as I said, which loads physical data, refreshes the physical data in the model, with Direct Lake, it's just a metadata. So data about data, tables, columns, column data types, stuff like that. And when you hit this refresh option for your Direct Lake semantic model, it just refreshes the metadata. And you will see that even though you have maybe, I don't know, 500 million rows in this data set, in this semantic model, when you hit refresh button, it refreshes in like 20 seconds. Try to do that with import mode with 500 million records, and you will probably need to wait a few hours. So that's a huge difference. Let me check questions. I see we have some, so maybe it's a good time to address them. Is it like we still need to maintain 2 data sources? One is original, one, let's say, enterprise data warehouse as an example, and second is in one lake. Thank you. Depends how your data is coming into one lake. So there are certain options that helps you reduce this data duplication. Think of shortcuts, think of mirroring. So there are certain options depending what is your enterprise data warehouse. You probably may not need to maintain 2 copies. But again, this needs to be answered once I know more details about the data source. How to get latest data in report like every minute? Do we need to set refresh, or Direct Lake would take it automatically? And one more question, how to use incremental refresh in Direct Lake, or it's not supported? Great questions. Thank you, VDN. I don't know that it's abbreviation, so great questions. So first, how to get the latest data, just as I mentioned on previous slides. So if you leave this option, let me show, if you leave this option by default turned on, it will automatically check every minute for the latest data, and then you just need to set auto page refresh feature to refresh the page, report page in Power BI report, because there is no scheduled refresh for Direct Lake models. Right, that's difference compared to import mode. Incremental refresh is not supported, so there is no incremental refresh in Direct Lake. I'm just going back to the previous slide where we've already been. So there is no incremental refresh. You do incremental refresh on your lakehouse level, and then this data is loaded on demand into Direct Lake model. Model itself cannot be incrementally refreshed. Can we use API as a data set source? So currently, you can't use API directly as a data source. Your data source can be either lakehouse or warehouse, nothing else. So your data must be somewhere stored in Delta format to be able to use it in Direct Lake. Okay, let's move on. To recap those key concepts relevant for Direct Lake, first is syncing, which means how do we handle the fact that new tables are added to a lakehouse? Do we want to add them automatically to a semantic model, or do we want to do that on our own? Then framing the operation of refreshing the Direct Lake dataset, which adds the information about the latest version of the file to a semantic model. Then we have a concept of transcoding. That's the process of loading columns from a table needed by the query, loading this table into a cache memory. And finally, we have a concept of temperature. I will show you this also in a demo. That's the concept that allows Power BI engine to keep frequently used columns in cache memory so they can be quickly served to the end user. I'll explain this in a demo, and yeah, let's do a short demo, and then I'll show you what I was talking about. So I'm in my Fabric workspace, and what I have here, I created. I have a semantic model created called CMS import and CMS underscore DL. Data comes from publicly available data related to healthcare industry, so you can also download it for free and play around. Fact table has around 220 million rows, so it's not the biggest one, but it's not the small one. So 220 million rows, it's fine for some basic testing of performance and so on. So what I did here, basically, I created two exactly the same semantic models. One is using import mode, the other is using Direct Lake mode. So all the tables, all the columns, measures, relationships, everything is absolutely the same. And then I want to show you now what happens with these two models. But before we proceed, one more thing that I want to show you. I'm now in DAX Studio. Probably you heard about DAX Studio if you work with Power BI. It's amazing free tool that we are using for different tasks, most often for troubleshooting DAX, but also DAX Studio contains a very handy tool called Vertipack Analyzer that helps us analyze the size of our data model. So in this case, I'm connected to my import mode model. You see, I'm connected to my import mode model, and I'll hit view metrics. View metrics will run a series of dynamic management views in the background and collect data about the data model size. So now we are collecting data about import mode model size. Let's wait. Okay. As I told you, it's 223 million rows. That's my biggest table. And if we go to summary tab here, you see that total size of this model is 4 gigabytes. Let's say 4 gigabytes. Here I'm connecting to my Direct Lake model. So it's the same model, but now in Direct Lake storage mode. And I'll run my metrics here for Direct Lake storage mode to see, is there any difference between import and Direct Lake in terms of data model size in memory. Hopefully this finished soon. Okay, yeah, there we go. So again, you see, again, the same number of rows, 223 million rows. But if I take a look at summary, it's 46 kilobytes. So 46 kilobytes versus 4 gigabytes. And that's what I told you. Nothing is loaded into a memory with Direct Lake. So this is just a shell of our data. We have information about data. We have tables, we have columns, we have relationships, everything. But we don't have real physical data stored in Power BI. Okay, this is the big difference between import and Direct Lake. Now going back to my Fabric workspace. And what I'm going to do, I will create a simple report, very simple one in import mode. So this one connects to import mode semantic model. And let's do something very basic like year. And let's do a row count. And let's do total claims. So you see, it's almost instant, like 220 million rows, but it's really fast. We have like, I don't know, 1 second for rendering the data. This is our import mode model. What happens with Direct Lake? Let me show you the same thing. So I'll go back to my workspace, and then I need to go back to my folder and create a new report on top of our Direct Lake model. So I'll create a report, and I'll do the same thing. So table visual, year, row count, and total claims. So you see the performance is almost the same as with import mode, almost the same. But what changes now? Let me go back to our Direct Lake model index to analyze the size now. And if I click view metrics, let's see now what happens, what we have here. It's now 4 gigabytes. So it loads all the columns or some of the columns. In this case, it's probably loading everything. We'll check. But now on-demand loading increases the size of the model in memory. And what I wanted to show you, another concept that I mentioned, is temperature. So you see that now columns are loaded into memory, and each of them, depending on their importance, it has its own temperature. And this concept of temperature allows the engine to decide which columns stay in memory and which columns will be kicked out. Because, you know, RAM memory is a limited resource, so we cannot load everything, all the columns from all models at the same time. So basically, the engine needs to figure out, okay, which columns are more frequently used by your users in the reports, and then try to keep those columns in memory, because when they are in memory, they're it's the best possible performance. They can be fastest served back to the end user. So in case I don't touch anything on my report, or let's say I add another column, so let me go and take, for example, I don't know, brand name to this report. So this will change again the temperature. Watch out. So now brand name is somewhere down below with temperature of 4.9 and something. Now if I run this query again, my brand name is here, and it has a temperature of 24. The more users are using this column, the higher the temperature of this column will be. And this temperature has higher chances to stay in memory and being faster served back to the report. You can also check with this query, you can also check which columns are currently stored in memory. So it depends how big your memory is. Yeah, sometimes the engine can decide to store more columns inside. So that's how with temperature, how it works with temperature, and how your columns are kept in memory. I mentioned at the beginning what's happening when there is no possibility to use Direct Lake. So by default, your queries will fall back to DirectQuery. And there are certain guardrails. I picked this table from the official Microsoft Learn documentation, where essentially you see, based on the capacity size, this is the column on the left, based on the capacity size, there are certain limitations for using Direct Lake. That means, for example, if you have a table of 500 million rows, you can't use F32. I mean, you can, but then your queries will fall back to DirectQuery. Also, this one on the right-hand side, the column on the right-hand side, max memory, this is just for the query. So it's evaluated per query, not per the entire model. There are certain dynamic management used to understand fallback reasons, and this Direct Lake behavior property lets you control what happens with a query in case Direct Lake doesn't work. So by default, this automatic option will be applied. That means if there is no direct lake, queries fall back to DirectQuery. Then direct lake only if there is no possibility to use direct lake for whatever reason, the query will return the error. And finally, DirectQuery only. That means there is no direct lake. You're just using DirectQuery for your queries. You can control this behavior. Yeah, I need to update this slide. So until recently, it was only Web UI or Tabular Editor. Now you can also do that from Power BI Desktop. Some final thoughts before I jump into more questions and before we move to riddles. Some final thoughts. I told you if you are a Power BI professional that you don't need to stress too much. But what if you're a Power Query guru? What should you do now? No Power Query in Direct Lake models. Then you open Direct Lake model, you can't use Power Query Editor to make transformations to your data, to apply whatever you apply to import mode models. You can't do that. There is no Power Query in Direct Lake models. But I have good news as well. You can use Data Flows Gen 2 as a way to leverage your Power Query skills. So you can apply all these transformations within a Data Flow Gen 2 and then store the result of this transformation in a Delta table. So it's one step upstream applying your skills, basically. What about row level security? Another question that I'm getting often. Good news and bad news. When it's defined on the semantic model, row level security is supported. When it's enforced on a tables that are queried through the SQL endpoint, so if you set row level security on a tables in a lake house or a warehouse, then there is no row level security for direct lake and queries will automatically fall back to DirectQuery. Some limitations, again, as of today, please be aware, you can query just one single lake house or warehouse, so there are no API sources, nothing else, lake house or warehouse. No DAX calculated columns and calculated tables, because they are created at refresh time. There is no refresh time in direct lake models, so essentially DAX calculated columns and calculated tables are not supported, except field parameters as a special type of calculated table. Field parameters are supported. Also, calculation groups are supported. No composite models, so you can't set some tables to be in direct lake mode, some tables in import mode. That's not possible. No relationships on date time, data type columns, and no partitioning. That means I mentioned there is no incremental refresh. With incremental refresh, essentially you're creating multiple partitions within your semantic model. With direct lake model, it's just always a single partition. Every table, no matter how many rows this table has, it's always a single partition. But you can apply partitioning on a delta table level. So again, one step upstream before data goes to semantic model. But what I suggest, always check the list of current limitations on the official Microsoft Learn website, because this is subject to change and it really changes. Some of the benefits of direct lake. First, as you saw, performance is really comparable to import mode. So once the columns needed by the query are loaded into a memory, it's, from technical point of view, it's the same as import mode. So your column is stored within Vertipack engine, and that's the same as import mode. Possibility to eliminate the serving layer. I see many companies introduced additional layer to serve the data to Power BI. Components such as Azure SQL DB, Azure Synapse, or whatever you use in that as that part in the middle between your data storage and Power BI. Now with this approach with Direct Lake, because Power BI can read data directly from your storage, essentially you can eliminate this layer in between. Refreshes in import mode, depending on the size of your semantic model, can be a really exhaustive processes and operations in terms of capacity units usage. And with Direct Lake, you don't have these problems because you just refresh the metadata. Shortcuts, another concept. Unfortunately, we don't have enough time to talk about that and discuss shortcuts, but you can use or multiple models can leverage same Parquet file with the concept of shortcuts. And if your company also has machine learning engineers or those guys working with data science stuff, they can use SQL or PySpark to query the same data directly from Delta tables. So it's one single copy for all use cases. To wrap up, Direct Lake is a fantastic feature. There is no single discussion about that. It is a fantastic feature, but it's not a one solution to rule them all. That's also important to keep in mind. I think these two sentences are key takeaway from this entire session. It is fantastic, but it's not a solution for all your problems, and it's not a direct replacement for import and direct query. And in that regard, if you're happy with your existing import models, don't switch them to Direct Lake, at least not yet, because of all the limitations that we listed that are still applicable to Direct Lake models. So if you're happy with your import models, just continue to use them. When to use Direct Lake? That's the $1 million question. And my opinion is, if your company already invested or plan to invest in a lake-centric solution, so you already keep your data in a lake house, Databricks, whatever, Fabric now. So if you're building a lake-centric solution within the organization, then it probably makes sense that Direct Lake becomes your default choice in front of import mode, because you have data already in a lake, and then you can leverage it directly and leverage all these benefits that we also examined. But again, those are my personal opinions, and I mean, we're all still learning when and how to use Direct Lake. Okay, few more questions I saw in the comments, and then we are moving to Riddle. Will it be registered to see it again? Could you share the slides in the Teams channel? I will share slides with the organizers, so yeah, I guess they can forward this. When the mode of import is live for the semantic model, I can't see the calculation of the measure in Power BI. Is there a way to do it? I suppose you're talking about live connection to a semantic model. So in that case, I can see the calculation of the measures. So measures are defined in that case on the remote model, on the analysis services instance. So you need to either open the original model, or you can just build new measures on top of this live connection model with, report level measures. Thanks for all the answers. Is it possible to implement role level security or object level security in Fabric to Power BI models? I think that was answered. So if you're implementing role level security and object level security on a semantic model, yes. If you are implementing this on a table, Delta table level, you're enforcing role level security, then still Direct Lake, you can build Direct Lake model, but then your queries will fall back to Direct Query. Okay, since there are no more questions, let's move on to Riddle. The first one is, how do we call the operation of loading data into a memory? Sina, maybe you can help with this part here now.
Oh yeah, for sure. I'm gonna just show up the answers on the screen. Yeah, for everybody. I'm just here to help you. One answer so far.
I think we have a winner here.
You wanna show the answer?
Yes, absolutely. So it's transcoding. Process of loading data in memory is called transcoding, and Shamim answered correctly.
Perfect.
Okay, we have another one. Should we run it, or?
Yeah, you can show the second one now.
Okay. Field parameters, are they supported in Direct Lake or no? They're a calculated table, type of calculated table. Yes, we have a winner, Levent. Sorry if I pronounced it wrongly. Yes, field parameters, regardless of the fact that they are a calculated table, they are supported in Direct Lake semantic models.
Perfect. Congrats. Yeah, just make sure Shamim and Levin just send us an email, and we will get back to you and send you the watcher. And thank you so much, Nikola. And if you want to just share something, just go ahead. Yeah.
Yeah, I just wanted to thank you and Merdad for inviting me to present, and to thank everyone for joining the session. And I hope it was useful. And now that you have a better understanding of Direct Lake feature in Microsoft Fabric.
Thank you so much. Thank you so much, Nikola, for your time and for today's session. That was really awesome. Perfect. So I'm just gonna add my slide real quick. So about these sessions, so we're already done with all of those. If you guys missed or join late, you can just rewatch them through our social platform, YouTube, LinkedIn, and so for the next and upcoming sessions. So the registration link are already announced. So you guys just can set your calendar and wait for them. And thanks again for attending today's session. And thanks, Nikola, for today's information and for being here. So, do you want to share anything, Nikola? Just go ahead.
Yeah, that was it from my side. Again, thanks to you and Merdad, and thanks everyone for joining. Yeah, have a great rest of the weekend.
Yeah, thank you so much. So these are our social platforms. Just make sure follow us, which is really supportive for us. And I hope enjoy the rest of your weekend. And thanks for being here again. So until next Saturday, 8 a.m. Pacific time. Have a good day.
Have a good day.
Bye. Thank you.